Good afternoon, ma'am. Thenmozhi, ma'am.
Good afternoon.
Devika from DSU, ma'am.
Few
Uh,
seconds. It's not audible. Give me a few seconds.
yeah.
She said she is not audible.
Yes. Am I
Uh,
audible?
yes, ma'am. You are audible.
Um, hold on a second. Hold on a second.
Oh, okay, okay. I think we are not audible too.
Yes, ma'am. I'm back.
Yeah, I'm audible, ma'am, now.
Yes. Yes.
Okay. We are waiting for few more participants to join, ma'am. We'll start in another 2-3 minutes.
No problem.
Good afternoon, everyone. I welcome all of you to this day 5 of the 6-day workshop of machine learning and its application. So, welcome once again, everyone. So today we have Dr. M. Thenmozhi as our session speaker. So here is a brief introduction to our today's session speaker. Dr. M. Thenmozhi, Associate Professor, Department of Information Technology in SRMIST, Chennai. She's having 22 years of teaching experience. Her field of interest includes data structures and algorithm, object-oriented programming, computer architecture, Python programming, machine learning, etc. She has done various publications on machine learning and deep learning in reputed journals like Scopus and SCI. And she has attended more than 20 national and international conferences and organized various workshops and training programs in data structure and algorithm complexity. She also got many honors and awards. To name few, she got Best Paper Award in 2015 and Best Computer User Award and Best Teacher Award in 2004 and 5. So we are very happy to have Dr. M. Thenmozhi as our today's session speaker. I welcome you, ma'am, on behalf of the entire management of Danan Sagar University, Bangalore.
Thank you. Thank you for the warm welcome.
Thank you for accepting our invitation and being here with us for this today's session, ma'am. Over to you.
Thank you. Thank you. Let me share the screen. Is the screen visible?
Yes, ma'am, it is visible.
Thank you. Thank you. Thank you for the nice introduction. I would like to give a brief lecture on some of the machine learning algorithms, and I've taken a telecom industry domain to analyze customer churn. It's need of an R. Okay, in any industry, you can apply to insurance or to banking or telecom. You take any industry, customer churn is the major part of it.
Excuse me, ma'am. Sorry to interrupt. Ma'am, can you go little louder, ma'am? It is not clearly audible at our end.
Okay, okay.
Okay. Thank you.
I've taken customer churn analytics for telecom industry. So I've taken some of the machine learning algorithms for today's discussion. Customer churn is the need of an R. It can be applied to any industry where customers should be given higher priority. So I've taken this telecom industry data set to apply the algorithm which I'm going to discuss today. I hope you would have had the basics of machine learning algorithms. So before I'll just brief about the basics before I get into the uh, get into the specific algorithms. So machine learning, as you all know, the major classifications we have is supervised and unsupervised, then semi-supervised also. And our supervised, we have the classification, like categorical and regression types, and we have many algorithms available for categorical type and for regression type. For unsupervised algorithm, we have major classification as clustering and rule-based thing. So I'm going to touch upon logistic regression, k nearest neighbor algorithm, and decision-tree algorithm. So I'm going to cover the most of the portions under supervised algorithm. So as I've already given a brief note on classification in machine learning. So you need to understand before applying it to any problem. You need to understand the strength and weaknesses of any model. That is very important because every model has its own advantages and disadvantages, or I would say it has got its own limitation. So based on the application domain, you need to find the appropriateness of the machine learning algorithm. So for that, we need to know how the algorithm works and whether it produces a very good accuracy of the model. Again, it depends upon the criticality of the application. The algorithm which you are applying for the gaming cannot be applied for life critical application because your parameters are going to be different for every application. So it does depend on the criticality of the application. When you're applying it to human lives, then the case is different. Yeah, when you're applying it to safety critical situation is totally different. Or we are applying it to non-critical application, then the accuracy can be compromised to some extent. But truly speaking, no algorithm is going to produce you 100% of accuracy. And with respect to data set, there will be some differences in the accuracy level also. So you need to understand it before you apply to your problem. And the another major challenge in addressing this is processing the data. When you get a data, you're not going to get a clean data. So how are you going to do pre-processing? I hope you would have come across all such thing already. I don't want to get into such things. Some pre-processing steps should be done to get a clean data, to remove noisy data and such things. After doing that, you are going to apply all statistical method. Um, almost all the machine learning algorithms are going to use these statistical models strictly. So we are going to discuss some of the models here. And finally, you need to know whether the model is fitting to your application. Then you're going to evaluate the model and you're going to finally use the model for prediction. This is like, as I've already talked about the classification, supervised and unsupervised thing. So it clearly defines an X and Y variable in supervised learning. So that's why we call it as supervised. And it predicts the continuous response under regression model. As I've already told, there are two types. You have a classification, or you're going to have regression model under supervised. When you get continuous response, for example, you're dealing with continuous data like weight or height of a person, or you're going to have some discrete data, but regression model is going to work for the continuous data. So the continuous data is given to the system for training, and you're finding a best model for that. Then you're going to use that model for predicting something. And the other model is categorical response. Uh, if you want to predict something as a spam or spam mail order, it's or not. Okay, such category will come under this. Or if I want to know whether I'll get salary hike or not, such questions can be answered here. This under supervised learning. Under unsupervised learning, it's going to deal with unlabeled data. So you will not have any knowledge on that. You're going to have a clustering concepts to to group the items based on the similarity, and then you try to find the hidden patterns among the data. Then you're going to proceed with that, and we call it as clustering. And the other thing is association rules. based on the based on the rules it's going to work. Actually speaking, the accuracy is not a good model performance measure. For example, I've taken this telecom industry data. You assume 100 customers, and you predict that there are 8 customers who are churn. Okay, so 8% will be the people will people are frustrated, and they may leave they may quit the service at any time. So 8% is detected. And if the model predicts that no one churns, suppose your model predicts that no one churns for that domain, then the accuracy of this thing is going to be 92%. So you are actually leaving 80%, and the accuracy of the model given is 92%. So you are missing critical customers, or the valuable customers who are going to quit their service. So you need to know, but I can't spend my whole time to understand all customers' behavior, or who may quit the service. So you can't make random calls. Also, when you are dealing with very large data set, it's again a difficult strategy. So how are you going to make it? Okay, some algorithms we're going to discuss for that with respect to that. And this is a you're going to have this confusion matrix. Instead of this model, you're going to have this, which gives you the true negative and true positive, or false negative and false positive. I'll get into this bit later. And you're going to use this ROC and AUC method to understand how the positive cases and the negative cases are separated. You know, the good measure. Well, get into logistic regression. Before getting into logistic regression, I would like to justify why linear regression cannot solve such why linear regression cannot solve some kind of problem. Sorry. Um, so according to linear regression, you'll have y is equal to mx plus c, that model you're going to have, and m is slope and c is the intercept. So based on this, we are going to predict the continuous. You're going to have a continuous rate of training, and prediction will be happening after the training is done. If we have a data scattered, and you're trying to fit, okay, suppose you assume there are some data on the um, data on the lowest level from left to right, and some data in the upper right corner of the chart. Okay, and I try to draw a straight line, the linear line, to fit the data. But most of the data would be missing, and I'm trying to fit the line, even though if I'm compromising on the error, even if it produces much error. So linear regression is actually based on the least squared method. That is, the error will be calculated based on the least squared method. It tells you the distance between the point and the straight line, the data points and the straight line. If it is less, then the model is good. If it is more, then the model is going to behave something wrong. So I'm trying to say this: why logical regression cannot be used means when you are dealing with outliers, when you have some data which is totally different from the average data, and you take some exceptions. In that case, if I'm trying to I'm trying to tilt the straight line to fit the data, and it is going to give very poor results. For example, if I'm predicting obesity of a person based on his weight. Okay, so I would say 75, a person who is weighing 75 kilogram, is coming under obesity category. So I am going to have only two outputs, that is categorical, either obese or not obese category. Only two categories I'm going to deal with. But linear regression is dealing with continuous data. So, like if I say 75 percentage kilogram is weighing high, and you are saying the person is obese, and same model, I'm trying to change the linear regression line to match some more points, to cover the outliers of the data set. Then there will be change in the slope, and there will be change in the y variable. So now the 70 percentage, 75 kilogram person will be categorized under not obese category, because of the change in the straight line, or the best fit is going to be changed now, and there will be some change in the, uh, when you try to project the line, there will be some changes. So it is going to drastically give a very, drastically, it performs very poor with respect to this. And such cases, when you are dealing with outlets, it's very difficult dealing with the linear regression. So what we want actually is, I need to have a model, instead of having a straight line. I want to have a squiggly line or a curve like thing, which fits the data with less error. I mean to say, the line or the squiggly line or straight line should hug the data with less errors. So if I want to do that, then I'm going to depend on the rely on the sigmoid function. That is a function we are going to use for logistic regression. It looks like a S-shaped curve. Yeah, we'll see the diagrammatic representation of such things in the upcoming slides. I'll show you this linear classification algorithm, and the dependent variable is binary. Yeah, of course, you are going to have only two outputs. You are going to say true or false, or 0 or 1, or something, yes or no, something like that. And this is used to predict the likelihood of an event occurring. So yeah, it is going to tell you whether it is likely to rain, or whether the event is occurring or not occurring, or whether someone is going to win or lose, or something like this. So this is basically working on the likelihood. Okay, so probability plays a major role here, and we are extending the idea of linear regression when y is categorical. This should be highlighted, because uh, this linear regression is not going to work for categorical output, but this thing, logistic regression, will work great for categorical thing. So what we do is, you have a set of data. You are getting a new data coming in, and you're going to classify that new data under S category or no category. Maybe call it as classification. And so the first step, yields estimate of the propensities or probabilities of belonging to the class. Whenever you get a new data, you're going to decide whether it falls under a category, or it falls under category B. That has to be, decided based on some parameter where you are going to push the item. The next step, we use the cutoff value on these probabilities in order to classify whether it is falling under which category. So cutoff value is again, research topic, like how you set the cutoff value, or we call it as a threshold value. When you reach that level, you are going to categorize it under some group. When it goes below the threshold, you are going to categorize under a different category, different group. Okay, but that does not necessarily be point 0.5. And as I told, it works for categorical, either true or false, something like that. So, but the probability is between 0 to 1. So the cutoff value is going to be 0.5. Generally, we take cutoff value as 0.5, but this need not be 0.5. And we said, based on the business case, you can decide your cutoff. So again, this point I want to highlight why linear regression cannot be used to predict probabilities. It doesn't have even the formula tells you that it doesn't deal with probability. So when you're dealing with linear regression, it can have negative values or positive values, um, uh, values that are greater than that. But the probabilities deal with values between 0 and 1. Hence, the function used should restrict values between 0 and 1. Whatever functions you are going to use, still now I have not talked about the mathematical model which you are going to use. I've tried to justify why linear regression cannot be used for some applications. So here I'm trying to introduce the probability, which is not included for linear regression. So these are some of the applications of logistic regression. So what is the likelihood that someone default a loan? If you want to say someone is going to cheat the bank, or they are not going to pay it properly, something like that. And what is the probability or likelihood of a person to get heart attack? So you'll have outputs only S category or no category. So for this heart attack may be due to an increase in the BMI level, or for the smoking habit of a person. Okay, that will also affect. But we don't bother about these factors. We want to know whether the person will get a heart attack, whether he is likely to get a heart attack, something like that. And we are going to say which one has the higher impact. If the person is smoking, or the body weight of a person, calorie intake, fat intake, or age of a person is also influence the person's cardiac arrest. So we need to decide which one is going to have a higher impact on that. I want to introduce one more term here, odds. Okay, this is generally used in arts, races, sports, and gambling thing. So instead of talking about probability of winning or contacting a disease, we talk about odds of winning or contacting a disease. How these are different, we'll see. So this talks about the probability. Odds ratio gives you probability of event occurring and probability of event not occurring. This is the odds ratio. Okay, so that ratio is given like this: p by 1 minus p, and the probability of application will be decided with odds ratio divided by 1 plus odds ratio. Just I'm introducing the terminology. I'm not going in depth about odds and probability. I just want you to understand there is a technical term called odds ratio, and that is reflected in the probability. And you need to know the math behind logistic regression. Logistic regression is otherwise known as binary classification. Yeah, it tells it gives the meaning, like we are always dealing with zero between 0 and 1. Then it is going to have a categorical output we are going to have. So obviously it falls under this category. So why not linear regression, that I've already discussed? Linear regression cannot work well for the outliers, and linear regression works good for continuous data. But we are going to deal with categorical output. So linear regression may not be it is not a good choice, I would say. You can apply linear regression to any model, but it may not be a good choice when you're dealing with outliers. And for some problems, the output is going to be closer to 1, or it is closer to 0. You will not have any other values in the middle. So you'll have most of the values skewing under 1, or most of the values skewing under the 0. So only these two cases we are going to have. So when such cases arises, we don't need a linear regression. So we are actually going for logistic regression. As I've already mentioned, you predict something, okay, based on the likelihood or the probability. The predicted value is going to be greater than 0 and less than 1, meaning it is between 0 and 1. We're going to use mathematical formula sigmoid, okay, which looks like S shaped, which looks like S. Okay, we call it a sigmoid function, or otherwise known as logic function. The formula is 1 by 1 plus e to the power minus x. This x variable, independent variable, can be further expanded using using linear regression formula. If you have coefficients, multiple coefficients, I'll go back to the slide. Suppose I take this particular question: do body weight, calorie intake, or the age of a person does have influence on a person who is going to be affected by cardiac arrest? So suppose you are dealing with multiple parameters. So my equation for linear regression for this particular problem would be b0 plus b1 into x1, b2 into x2, b3 into x3, because b0 is just an intercept. b1, b2, b3 are going to be the factors which influence the y variable. So I have taken here calorie intake, fat intake, or weight of a person, anything, any three parameters I'm taking from this particular example. And linear regression will be represented with this formula: b0 plus b1 into x1, b2 into x2, b3 into x3. So b0, b1, b2, b3 coefficients need to be found. So this is just linear regression formula. We are going to have it in logistic regression. As I told you already, this linear regression, logistic regression is an extension of linear regression. So you are going to have this sigmoid function. This is 1 by 1 plus e to the power minus x. This minus x can be further extended if you have multiple parameters. I'll shorten it now. This is the sigmoid function. So you'll have 0. This is the origin, and you have values up to 1.0. That is the maximum value that you can get, and this is your sigmoid function. And suppose you have values from minus 6 to minus 2 here, that will be represented in this particular portion. And when you have values, upper values between 2 to 6, this will be represented here, and slope is here. Suppose you want to get the threshold value. If it is somewhere around 0.5, you're going to project the line here. This is the cutoff line, and I can project the line onto x-axis like this. This is going to be the cutoff point, and it need not be 0.5 all the time. It's again a research topic, like how are you going to set the threshold for any structure. This is like how are you going to uh, carry out the procedure. So first is like you need to understand that what are the steps need to be done to implement logistic regression. So first is you calculate the logistic regression. For this, this McFadden's formula is used, and the scenario is explained here. Um, I'll try to explain it with the example. I mean, with a diagram. So you run the logistic regression model using this McFadden model. Then individual coefficient significance. I've tried to explain with P1, B2, P3, three different coefficients that need to be found to get y variable, and you're going to apply it by knowing the odds ratio and probability. As I've already told, this is an exponential function. So there's an exponential of coefficients of linear regression model. So it says if you have b naught plus b1 x, which is a linear equation, linear regression formula. If you find the coefficients of this linear regression and find the exponent of those coefficients, that is the odds ratio. And after finding the odds ratio, you're going to apply it in the probability function. Odds divided by ratio divided by 1 plus odds will give you the probability of event that is likely to be happening. So after doing all this, the mathematical calculations, you are going to predict the model based on training and test set, and the measure to calculate the accuracy measure using confusion matrix. This is just a case study I've taken. Stroke prediction using logistic regression. These are the variables we have considered. Okay, gender, age of a person, whether he's married or not, the working style of a person, resident type, health status, okay, whether he has hypertension already, he has a history of heart disease, BMI value, whether he has a smoking habit or something like that. And the final output is going to tell you whether he is likely to get a stroke. That is the final output we are going to predict. These are the input variables. Among these input variables, anything can act as a, anything can have a higher influence of the output stroke. Even if the person doesn't have smoking, also will get a stroke. Other parameters will decide that. So this is the output we got. All the coefficients values found, and we are trying to say either the person is going to be going to get cardiac stroke or not. So here, according to this scenario, a person who smokes has 42 times more odds or 98% of the probability of getting stroke. And here, sorry, this point 54 tells you that an increase in average glucose level by 1 unit raises the odds of getting stroke by 1.2 times. Okay, this is what it shows. This is with respect to the glucose level of the person. And this is with respect to the smoking habit of the person. This has the higher influence. And before I get into the other algorithm, I just want to discuss more on the missed out points. This the logistic regression can be applied to problems where the problem is linearly separable. When there is a clear when the problem is linearly separable, only you can apply this. And then how to calculate the logistic function we already discussed. That is 1 by 1 plus e to the power minus x, and the minus x will be extended with the coefficients if you're dealing with more number of parameters. And then this calculating the coefficients mm, can be done with the different methods. I'm going to discuss here the gradient descent method. Assume you're standing on the top of the mountain and you want to get down. Okay, so what I do is, like, I will stand on the peak and I'll try to make one step. I'll make one step and I look for all the possibilities to get all the possibilities which are closer to me. Meaning, I try to find the shortest distance from my point, and I'll make one more step. Then I'll try to find the next step. So you don't have to look at the entire my mountain to get all the steps. So every time you make new steps based on the possibilities. Okay, so likewise you're going to have a calculate the b0, b1, b2 coefficients which are involved in the problem. Initially, we assume point 0 for b0, b1, b2, and we try to um, calculate values of b0, b1, b2 like this. Intuitive method is like b1, b0, b1, b2 will be assumed as point 0. Then we are going to apply to the formula 1 by 1, 1 plus e to the power minus of b0 plus b1 into x1 plus b2 into x2. It can be further extended when you have a number of parameters. This method is called the gradient descent method. Once the output is predicted, so if it is greater than 0.5, or you are going to say the person more chances of they're more closer to 1. So we assume the person is closer to 1. If the value is less than 0.5, then you're going to say the person is closer to 0. So if I have 0 tells the person is not likely to get cardiac stroke, and he's likely to get cardiac stroke when the value is 1. So if it is zero point 0.5, after calculating the coefficients, and you understand that the value is zero point 0.5 and above, then you are going to say the person is likely to get cardiac arrest or stroke. Or if it is closer to less than 0.5, then the case is different. So, like logistic regression works best for outliers, as linear regression fails for such cases. So, we prefer logistic regression would be the appropriate method when you're dealing with categorical output. I'll get into another algorithm, which is KNN. I'll try to expand it. K nearest neighbor algorithm. Here it works differently. So I'll try to explain what is memory and what is learning. If you store something, you say it's memory, right? Memory is the process of recording. You record something, you store something, and whenever required, you're going to retrieve it. Okay. Learning is a process or behavior of acquiring knowledge. You acquire knowledge by learning it, and that is the ability to implement the information and make use of it in the practical circumstances. So this KNN has different names. So the K nearest neighbor algorithm we used to call memory-based reasoning, for example-based reasoning, instance-based reasoning, case-based reasoning, or otherwise called as lazy learning. I'll tell you why we call it as lazy learning algorithm. It's very powerful for with respect to classification. How are you going to classify things? Whenever you get a new data point, how are you going to classify it? The unique point here is it requires no training for making predictions. Very important. It requires no training for making predictions, which is the major. It's a difficult portion of any machine learning algorithm because most of the time and energy cost will be spent on the training portion. Here we are not going to have such thing. Okay. And it is widely used to find document similarity or pattern recognition thing. Okay. It can identify the patterns based on its similarity. When you get a new data item, you are going to compare it with the existing one, and then you will decide whether the new data is of the same type or it is different. I'd like to pronounce a proverb here. Uh, Birds of the same feather flock together, people used to say. So when similar things are grouped together, where similar things have the tendency to join. Okay. So likewise, when you get a new data point, that data point is going to be grouped under groups, grouped under some groups based on its similarity. If it is very similar to the items which are already existing, then it's going to be added in that group. So it is used for pattern recognition. And it is lazy because it does not try to learn a function from the training data. As I've already told, it doesn't require training, and it doesn't come under non-parametric model. This is very important. This is a major difference between linear regression and KNN. Linear regression is a parametric model, and if you say y is equal to mx plus c, x is a independent variable, y is your dependent variable, and y always have the influence of x variable. That's why we call it as parametric. But here, KNN is non-parametric model. It doesn't depend on the parameters. Okay? It doesn't involve any of the parameters. And then it memorizes the pattern from the data, memorize the data, patterns from the data set. So it's one of the supervised machine learning algorithm. I'm trying to compare the methods, okay, the algorithms, whatever I'm discussing, with the linear regression model, which is a very simple and which is very simple method, and a straightforward method also. So when you don't want linear regression, when you're not going to depend on the continuous data, and then you have different scenarios, you prefer different algorithms. But KNN differs from linear regression with respect to the parameter that it uses. Linear regression uses parameter, but KNN not. Both the methods are coming under supervised machine learning algorithm. So the thing is like, how are you going to implement it? When you get a new point, okay, a new data point, how are you going to decide whether it can be put in some group and whether it can't be put in that group? because of its differences in nature. If there is more similarity, then you're going to put it into group. So how are you going to find that there is a similarity if there is no similarity? So thing is, when you're dealing with numerical data, there are methods, to calculate the distances. If I get a new point, okay, that point, the point should be compared with the existing points, by just comparing the distances. The one which has closer, then less distance, or closer to that point will be considered for grouping. Uh, Most of the time, we use the simple method Euclidean distance measure algorithm, or squared Euclidean distance measure algorithm. But we used to go with the Euclidean distance measure because squaring will take it is costly when you're dealing with the square root. It is costly, so we can prefer Euclidean distance or the Manhattan distance. Manhattan uses the absolute value. So when you get a you know in Euclidean distance formula, we are going to square the differences. We are going to square the differences. It's because when you get negative value, there is a possibility of positive values getting cancelled. So to avoid that, we are going to square it. That is there in the formula itself. And then another major point with KNN is you need to decide the value of K. Okay, so K can be anything. Like I can start from 2 also because K cannot be 1. So I can start with 2. So two items can be grouped together, and the one data item is already there. A new data item comes in, and I'm going to find the distance between these two, and I'll decide whether I can put it in that group. This K value is again based on the intuitive method. You decide whether the values can be 3, 5, 6, 7 or something. If we get more K values, and accuracy of the system will also be that increasing. So algorithm segregates unstable data points into well-defined groups. That's the idea. Sorry, I missed the diagram. Yeah. So this just I know the data which I have. These are the data points. Assume these are the data points which is already existing. I get a new record. Okay, this resembles record. Of course. So you're just going to compare it with the shape or other features of this, and you decide whether you can put it in this. Okay. So if it walks like a duck or quacks like a duck, then it's probably a duck. That is your idea. This is how this nearest neighbor algorithm works. Okay, same thing as explained here, like how you assume values for k, that is 3, 5, 6, 7, 9. Some examples are given here. So determining the value of k plays a significant role because if you get more values, that there will be significant improvement in the accuracy. K values less, then there will be decrease in the performance. It goes like this. So a large k value has benefits. Okay, that is a binary conclusion, which include reducing the variance due to noisy data. But if you get smaller data, then there will be much what I would say like the accuracy tends to be low. This is just an example of nearest neighbor classifier. One nearest neighbor classifier. So we are I've written it's just handwritten thing. You are having 4 as input. It's going to predict that the output is going with the training set it compares, then it is going to say it's full. Likewise, you have 2 nearest, 3 nearest, or it can be n nearest neighbor. So now, k, it's a general name. They say it's a hyper parameter. The value of k should be decided, and that will influence the performance of the system. As I've already told you, k small model is complex, meaning you're increasing the number of groups. If increasing the number of groups is going to increase the complexity, vice versa. It means that model memorizes the training sets and cannot predict the test set with good accuracy. If k is big, then it is less complex. We require three things: set up stored records, the distance metrics to compute the distance. You choose Euclidean or squared Euclidean or Manhattan or cosine distance, anything to calculate the distance, and decide the value of k. When you're dealing with numerical values, you go with the Euclidean or squared Euclidean or cosine distance. Or when you're dealing with categorical variable, you can use Hamming distance measure. Just an example. Just this slide just shows the formula of Euclidean distance. As I've already told, this is one point and this is one point. You try to subtract these two to know the distance, and it is squared just to avoid the cancelling of values due to negative thing. And this is squared Euclidean distance. This is just a sample I'm given here. You take 2 points, okay, 1, comma 2, 3, comma 3, and you calculate the distances. That's 2.236. Manhattan distance explanation is given here. It takes the absolute value. So instead of squaring it, you're going to take the absolute value. It doesn't deal with what sign. I'm coming to the advantages of KNN. Analytically trackable. It is very simple to implement. So here, it's a lazy learning algorithm because you require no prior knowledge, okay, to make real-time predictions. You don't have to worry about that. Whenever a new data comes, you are going to add it in the existing, or you will say it's not closer to the existing points. This makes a special, for KNN algorithm, it is very fast, because of this feature. And they compare this KNN with support vector machine or linear regression also. But it is, faster than other algorithms what is mentioned here. The distance function is also a straightforward method. And when it comes to disadvantage of KNN, large storage requirements, because every time you get a data, like I've told the memory, it stores the pattern, so it requires more memory. Computationally it requires much memory is not free of cost, so you need to bear that cost. It is associated with cost. And KNN algorithm, does not work well for high dimensional data. So when you are dealing with large number of dimensions, it's difficult for the algorithm to calculate the distance in each dimension. So when there are more dimensions, then complexity will also be increased. So distances between points towards every dimension should also be calculated. That's again a tedious process. And again, with respect to the higher dimension, when you're adding a new point, calculating the distance of the new point with all existing points become higher. It's again costly, and it does not work well with categorical features because it is difficult to find the distance. Of course, we have measures to calculate the distance, but it is as it is uh, um, with penalty, I would say. And these are some of the applications of PNN. Currency exchange, understanding and managing financial risk, credit rating, loan management, all this pattern recognition. Getting to decision trees. Actually, um, taken this logistic regression to compare logistic regression with linear regression, because linear regression is the basic model, and why we are actually having why we need a logistic regression. I try to explain. Then we introduced KNN algorithm, K nearest neighbor algorithm. Then, because of its simplicity, we use KNN algorithm in most of the situation. But when it comes to larger dimension, the accuracy of the system is going low. So that is the note, that point to be noted. This is the disadvantage of the limitation of this method. Then the third algorithm, the decision tree. It's actually a hierarchical tree structure. Decision tree is a hierarchical tree structure, and we understand that understand the importance or the advantages of decision trees. Can I hear from the organizer? Any of the organizer?
Yes, ma'am.
Uh, can I continue, or you need a break?
No, ma'am, you can continue.
I can continue.
Yes.
Thank you. So, like, it's hierarchical tree structure advantages, disadvantages. We very well know. Like you have a node. Basic terminologies. I'm saying, like, you have a root node, you have a sub node, so you have a leaf node, which is the last node in a tree, and hierarchical structure should be constructed first. Okay, construction of hierarchical tree and construction of tree itself is costly. That's a major portion of this algorithm. Like, how are you going to construct a tree? So once the tree is constructed, then processing with respect to trees will be very easy. So it consists of nodes and branches, and each node makes a decision. So you will start at the root node, and you will go for splitting the node, and this splitting is happening based on the decision of root node. Then again, splitting is happening with respect to the node's decision. And when you have more number of parameters, okay, more number of decisions and more number of parameters, then your tree is going to be very long. If how much ever is the uh, length, uh, parameters involved, it's going to take log n time complexity only. That is the maximum time it takes. So we prefer tree-like structures because of its time complexity. It takes less time. It is root node we use. That is the first data. Okay, the first data we are going to add it in that. And branch node and leaf node is the last node, and this is actually recurring function. In splitting of node will be a recurring function in decision trees. So here, if I go with the CART model, that is classification and regression tree model. Okay, I can use this decision trees for classification and also for regression problems. So if you're using it for classification, the posterior probability of all the classes is reflected in the leaf node, and the leaf node belongs to the majority of the class. Meaning, you will get better understanding. You'll get the problem solution in the leaf node, because it cannot be further subdivided. You have put all the constraints. Okay, when you're splitting node in the tree, finally you reach the leaf node. After executing all the functions from root node to leaf node, you are going to end up constructing. You are going to end up splitting. So you'll have to continue splitting the nodes as long as there is no input parameter, or we cannot go further. Okay, we can go still further. That point is the termination point. You will have to stop it. The regression problem, average or median value of the target value is considered, and as I've already explained, creation of data split should be done at every stage and every level. There will be a split, and there will be subsets, and subsets will be further subdivided. It goes like this until the end. So algorithm stops splitting the data when the data with the subsets are sufficiently homogeneous, or you can, when all the parameters constraints are addressed. So here the decision tree algorithm learns, as I've already told, learning should be there. Like you are going to construct a tree, and the decision tree algorithm learns, in every step, and it is learning is through the optimization of the last function. I'll explain it in the upcoming slides. So for classification problems, the loss function is measure of impurity. Okay, impurity. So every time you go for splitting, you'll have to decide whether whether that node going to be in the uh, first level or in the second level or in the third level based on its importance. If the value is, if the parameter is highly important or prioritized thing, then you are going to put it in the topmost level. So level this, if you are changing it or you are trying to construct the tree without just in an ad hoc manner, that's going to be reflected in the worst result of the tree. So every time you have to calculate the impurity of tree structure using different methods. Gini index method, entropy. We have different method to calculate the impurity. The regression problem, as I told you, we are applying it for regression and also in the classification thing. So the objective of regression is to minimize the variance in the target column. So every level and every column, target column, you are going to, you're trying to minimize the variance. That is very important. That will improve the accuracy of things. This is just a sample, how it works, that is measuring impurity or heterogeneity of items. So yeah, as I've already told, decision trees will be divided or splitted till you reach the homogeneity. Here, this just a simple example shows how are you going to deal with the heterogeneity. There is a bag of 50 balls in this sack, and we have different colors: red, green, blue, white, yellow color. So we'll have to pull out one ball from each bag with closed eyes. If the ball is red, okay, you lose the prize money that is accumulated already. If you get green, you will have to quit. If you get blue, you lose half prize money, but you can continue. If you get white, you lose quarter price of money and then you can continue. If you get yellow, you can skip the question. Okay. So this is how this is your input scenario. So this states that where you have to decide, and your decision can result in various outcomes. With equal probability is said to be the state of maximum uncertainty. So probability of getting red or probability of getting green or blue or something else. Okay. So it deals with probability. That's what it says. If you have a bag full of balls of just one color, then you're not going to deal with uncertainties. Problem arises when you're dealing with heterogeneity. When there is when you're dealing with homogeneous data, then there will be less uncertainties. That is always it. So you are dealing with just one color, no uncertainty. And then the more the homogeneity, lesser the uncertainty. That's what the same point. Here, the uncertainty is expressed as entropy or Gini index. Gini index, I can prefer Gini index because of its simplicity. Suppose you just want to calculate the impurity at each node, and the formula would be very simple. One is probability of s minus probability of s squared minus probability of no square. Then it is going to give the Gini index. Any index should be calculated for every node. As I told already, every node there will be a split. Every node is going to be splitted, and each node will have a further split, and it goes like this. But the challenge here is which node is going to act as a root, that we need to find. We have so many parameters. For example, I can take a data set with parameters, chest pain, good blood circulation, blocked arteries, and heart disease. So you are going to predict whether the person is having a heart disease based on chest pain. If the person is having chest pain and he has got good blood circulation or he has blocked arteries, then the person is going to have a heart disease or not. So your output is going to be yes or no type. Okay, this is the example I have taken. Here, every cell will be filled with data with yes and no. For example, the first row if I've taken as chest pain, the person doesn't have heart chest pain, doesn't have a good blood circulation and blocked arteries, and you say there is no heart disease. If the other record says the person is having chest pain, having a good blood circulation, having blocked arteries, but he has heart disease. And sometimes, even if the person is having chest pain, good blood circulation, and no blocked arteries, and the person is not having no heart disease, even though he has chest pain, he's not categorized under heart disease. So there are factors, which you can't say this factor is going to be the uh, major factor. So I can say chest pain or blocked arteries or good blood circulation may be influencing my output more. So for this, we are approaching a greedy method. Greedy method tells you you are going to produce a suboptimal result every time, or you call it as a local optimum. You are happy with what you have. That is the greedy algorithm. Like you produce every you produce some solution and you are happy with that, and you go to the next level, go to the next level, finally you're going to reach the global optimum. So greedy algorithm, it is decision trees are work based on the greedy algorithm, greedy nature. So what I do is I'll have to decide now which node should go to the root. For my example, I've taken chest pain, good blood circulation, and then I've taken blocked arteries. Finally, the output is going to be the whether a person is having a heart disease or not. So in this procedure, so first intuitively, or I take some node as randomly, and assume it's going to act as a root node. Okay. So we have three attributes: chest pain, good blood circulation, and blocked arteries. So which goes to the root is the major challenge for us now. Okay. So every time you will have to calculate the cost function. Suppose I decide a chest pain, okay, as the root node. First is the chest pain, and next I have heart disease. Okay, I'm going to say based on the data which is available with me, I'm going to have divisions like this. Chest pain, just a random pickup. Okay, I've randomly picked up this chest pain parameter and put it as a root. And you decide whether we go to the left or we go to right side. If he has chest pain, then try to calculate the number of S you got. If the person who are affected with heart disease, yes, person who are not affected with heart disease should be calculated. You sum up everything and you put it in the left side. And if the person doesn't have chest pain, and you're going to find the possibility of the person is having a heart disease or not, you calculate it. And both sides, you have a node now which says a person with the heart disease is yes or no. And
Excuse me, ma'am. Sorry to interrupt.
yes,
We are seeing a measuring impurity or heterogeneity slide. So that is what the slide you are using.
I'm using this slide. I'm trying to explain an
Oh,
example.
okay,
I
okay,
have
okay.
not put it here. I'll show you a different example in the next slide.
Oh,
I'm
okay.
I'm just saying the procedure.
Oh, okay. Thank you.
So here, chest pain is taken as root, and you decide. Okay, you are trying to calculate the Gini index for this. So this is done at the first level. Next, what I do is it's a greedy approach. I just try with another attempt. So I take good blood circulation as a root node, and I have to go for the further subdivisions. We will have to calculate the number of S and number of nodes, and then I will have to have the third node, which is blocked after this, decide number of S and nodes. And after this, you calculate the Gini index, having this formula 1 minus probability of S and minus probability of no. This way, I'm calculating Gini index for all the tree structures which I've created. Okay, so I've created a tree structure for chest spine, blocked arteries, and for fall. That is going to be going to act as a root node. Then again, the next level thing, you need to decide which node should be in the second level of hierarchy. So for that, again, I have to try it with the greedy method. This, sorry, the second node should be added with the tree, and whether the same procedure should be followed for the second, and calculate the Gini index. Now this is for the with more than two levels that has to be done, and this process should be repeated by adding every node, by adding all the nodes in the tree, and that is the end point. Like you will have a good the root node, and you're going to add the rest of the nodes, blocked arteries, chest pain, good blood circulation, everything in the tree, and the final tree is going to be a single tree. uh, Final tree is a single tree. Single tree will represent the after calculating the Gini index, by calculating the impurity of the node only, you're going to add it in the tree structure. So the final tree is going to be the result for you. And same way, this is just an example, of shipping mode. Order prior, you're going to order priority of customer based on the customer location. Okay. This just I don't think whether it is visible much. I can read the columns. Okay. So order ID is there, order date, priority, high, medium, or not specified priority, quantity of items, sales, discounts offered, then the shipping mode. Shipping mode is one parameter, profit, and some more of there. Here, the point is like, how are you going to construct a tree structure? So that is the point. So among these parameters, which one is going to the root, we need to decide. Here the sales data is taken as root node. Then based on its data nature, we have express air, we have regular air in the data set, and based on this, regular or express air, you're going to have low priority or high priority thing. Okay. So we have considered sales data, regular air or express air, and then low priority or high priority of excuse me, low priority or high priority of things. This actually, after deciding this as root node, whether to add regular air in this level should be decided based on the Gini index. So you need to calculate the number of a regular air here. That is a possibility. Total number of S for regular air, total number of no for regular air, and for express air you have to calculate. Having these two, you will have to apply it in a formula to calculate the Gini index. 1 minus probability of regular air squared minus probability of this, you will have to find. Gini index should be calculated like this. And next is, whether the order is of low priority or high priority. The same procedure should be done. Since, as I've told, it's a recurrence procedure. So you'll have to add more and more nodes based on the same procedure. So So here, after creating the sub branches, okay, the total entropy of the sub branches, should be less than the entropy of the parent node, because that has the highest priority. When you have something as root node, that has the highest priority. The more drop in the entropy, the more information you gain. Just an output, we got the some calculation done for entropy to get the maximum entropy and information gain. So here, this These are the points related to the termination of the algorithm. As I've already discussed, termination of the algorithm should be done when the leaves cannot be further subdivided, or when you have to abruptly stop terminating it, or it reaches some prefixed depth. So that is the longest path from the root node to the leaf node. Or till all the points are covered, or till all the nodes are added in the tree. These are the termination uh, criteria, like when you have to stop the recursive procedure. A formula for information gain and entropy. For these values 40, 40 root node, then for these values it is being calculated and it is given like this 1.81 and 0.81. So more the information gain is for the root node. These are the common measures what I've discussed already. Gini index, entropy. These are the common measures we used for calculating the purity of nodes. Because this is very important, like how you construct a tree, based on these two things. The different types of algorithms we have. Decision trees algorithm, iterative dictomizer is one algorithm, and creates multi-branch tree. What I've discussed, yeah, what I've discussed now, it's not a multi-branch tree. In iterative dictomizer deal with the multi-branch tree. It's again working on the greedy algorithm procedure. And the other method, C4.5 succeeded ID3 by overcoming the limitations of feature required to be categorical. So the previous method works well for categorical method. And then the one more method is there, which uses less memory and builds smaller rule sets when you're adding new nodes into the tree. The model which I have discussed so far is CART, classification and regression trees. We generally call it as CART. It supports numerical target variables, and it does not compute rule sets, because when you're dealing with the numerical sets, it's very easy to calculate, like the Gini index also. You calculate the number of S and O, and you will proceed with the Gini index or no, entropy. But CART is a binary tree. That's what I have discussed so far. How to have two divisions all the time. When you have a node, how you will have obviously two divisions every time. Advantage of decision tree is very simple, very fast in processing. It's effective also. Uh, so it does well with noisy data. So you don't have to worry about noisy data. You don't have to worry about missing data. It's a great challenge. Missing data is a great challenge when you are dealing with large data set. And here in hierarchical structure, you're just going to repeat the procedures by adding nodes or by calculating the impurity of nodes by using any of the method. Then it's a recursive procedure. That's it. But it deals with missing data clearly. And then decision trees will work well for numeric and categorical variables. What I've dealt with is numerical inputs, and you don't need mathematical or statistical knowledge. This is very important. But when it comes to tree complexity, or when it comes to multiple trees, then the case is different. But here you are not going to adopt any mathematical or stat. You don't require any statistical knowledge on this. And disadvantages, like it's biased towards splits or features, have large number of levels. Like yeah, of course, you use a common method to calculate the impurity, and when you have a large number of levels, they say it's a disadvantage. But with respect to the time complexity, it's not a big thing. It is it's an advantage only. And small changes in the training data can result in large changes. This point is very important. Even a small change in the training data will have a major impact on the result set, because every time you add a node to the tree, you calculate something and you try to push it in the level 1 or level 2 or level 3. When you go down the tree, your distance from the root is going to be increased, and the maximum number of nodes you are going to travel, everything is going to be different. So there is a small change in the training data, it's going to affect it. And large trees can be difficult to interpret. They say when you have more number of data and columns or attributes, then it is very difficult to interpret this. That's all about theoretical explanation of the algorithms what I have, and I plan to show the implementation of Python for these algorithms. Yeah, bear with me for a few seconds. Hello. Sure.
Ma'am, can you able to hear us?
Yes.
Ma'am, in the chat section, there is one question.
Yes.
Can you explain how to calculate entropy in decision tree?
Okay.
I am not able to hear.
Hello? Hello?
Yeah. Hello.
Ma'am, can you hear us?
Yes. Yes. I'm trying to execute the code. Please. Few
Uh, oh,
seconds.
okay, ma'am. And meanwhile, you can just see the chat section, ma'am. There is a query for the.
Yeah. Is the screen visible?
No, ma'am. No, your screen is not visible.
Okay, so
Ma'am,
yeah.
yeah, I think it is better if you share your entire screen, ma'am, so that when you switch the windows also it is visible to us.
But I'm not able to. Okay, okay. I'll take it. You want me to share the complete window? Yes.
Entire screen will be better so that if you switch the window, it is be visible to us.
One second. Is the screen visible now?
No, ma'am.
Yes, yes.
Yes, yes, it came now.
Okay, thank you.
Uh,
This is the CSV file I've taken. Yeah, I'll come to the comment section after this. Um, this is CSV file. Okay, so this is for telecom industry dataset, and I have a state account length, area code, phone number, whether release offering, opting for international plan. So these are the parameters that is taken, and the final output is going to be whether the customer is churn or not. And I'll run the code. So actually need to import the necessary libraries. That's what I'm showing here. And training data and testing data is split based on 70-30, 70%, 30% split is taken. And these are the libraries, normal libraries that we have used for this. And then linear regression is there. And for calculating the accuracy measure, we used conclusion matrix that is also imported. And this is the data set. And this is right actually into df. That's a variable we are using. And I'm trying to display the top few rows here. This is just showing the top five rows using this keyword head, and then this is just want to display the number of rows and columns here. It shows here state all the parameters that we have taken into consideration. how many, what is the duration of those calls and frequency of calls, account length, area code, because it impacts, the area code will also be a major impact on the result. So that is being considered, because in every area, some network will be famous. We are not going to use all the networks in all the areas. It has an impact on the results. If you are the churn, it just counts the number of data what we have. Just a diagrammatic, that's a visual representation of this. Here, the output is showing like 85 percentage of the people are not going to be churn, and 14%, approximately 15% is are in the churn category. That is among 2,500 or more than 2,500. We consider the 15 percentage of the people are likely to be uh, churn. Okay, that is actually given here, very small percentage, and these people will be addressed by the service provider. And this just a description of data. So this just show the area code and churn. So this is with respect to the area code for 408, and this blue is going to be false. And churn rate will be false, and this orange color shows the churn percentage. And for this 415, this area code, the churn rate will be more for this particular area. The data is more. So the maximum number of customers, area code with maximum number of customers is this, that is 415, and the churn rate is also more here. And this is for the international plan. So here just displaying the categorical column. If you want to consider, categorical type of thing, only 4 columns are there. So we are going to deal with that. Only four categorical column, and that is being displayed with state, phone number, international plan, and the voicemail plan of the categorical thing where we have. The pre-processing is done, and then after pre-processing, it shows the output and the two records we are taking. So with respect to area code 415, now I get into logistic regression.
Excuse me, ma'am, you are showing the Jupyter notebook, right?
Yes,
Okay. Okay.
it's Jupyter notebook. So now I get into logistic regression, and as I've told already, the training split is 30, uh, 30 70 actually. 70 is for training and 30 is for testing type. And logistic regression is split all. So accuracy for training test split is displayed, and K cross validation method is used to measure. Cross validation is done. That is good, and stratified cross validation is also done. And finally, we display the accuracy of logistic regression for this telecom industry. So the training test split is 87 percentage accuracy it shows, and for K-fold method is showing 85 percentage. These are different, K-frame, cross validation methods, which measures the accuracy of the algorithm. And And accuracy of repeated random time test split is 85.96%. So with simple k-fold method, we tried, and for stratified method, and for the random inputs chosen, and it is tested for logistic regression, and that input is accuracy is shown here. Because I didn't deal with the SPC, so I'm skipping that. This is a random classifier. I think I have not covered it. Random classifier, it's an extension of decision trees. In decision trees, actually, I've tried to include all the nodes in a single tree. So final tree is going to be a single tree. After calculating the Gini index or the entropy, you will have a single tree in the case of decision trees. But random forest is different. Like you will have different trees, and you will decide which tree. Every tree will have its importance. So which tree is going to have a higher impact will be considered. So that accuracy is shown here. It gives better accuracy. It is more than 94 percentage, and same cross validation methods are used for this also.
Excuse me, ma'am.
Yes.
Ma'am, in this screen, we could able to see that Jupyter notebook with the data alone.
Data alone. I'm
Yes.
showing it. I'm showing the code.
Yeah, code with some random data which is available. We could able to see. Is that you're showing, ma'am? Or
I'm showing the notebook, Jupyter
yeah,
notebook.
Jupyter notebook. We could able to see some numbers. Yes, no. Is that fine, ma'am?
No, I've shown previously the CSV file which I had. CSV file I've showed. This is my
Okay.
CSV file.
Okay,
Not
ma'am.
in the Excel format. I've shown it in the Jupyter notebook itself. I'm
Okay, okay,
using the
okay.
Excel here. But here I'm trying to explain the algorithms which is applied for the telecom industry data, which is the
Okay.
CSV file shown
Yes.
here.
For the same CSV file, you're telling that we can apply the various
Yes,
machine learning
yes,
algorithms.
various machine learning algorithms what
Yes,
I've
yes,
discussed.
fine.
And this logistic regression, I've said it is for categorical type, yes or no type. So I've tried to collect some categorical data from here, from this data set, and logistic regression has been applied. Then this method, random forest tree is applied, and then k nearest classifier. Uh, According to k nearest classifier, there are major thing is like you have to decide the k value. After that, you're trying to calculate the distance of the new point with the existing point, and if the point, if it is closer, then you're going to add it in the group. Otherwise, you're not going to add. So it is again depending on the k value, which is taken. Again, same cross validation method we have applied here, like to know the accuracy of the show the results here. So accuracy is 89 percentage using k-fold and repeated random check. It gives a better accuracy. I have not covered grading boosting. It is just confusion for using true positive or true positive, true negative, and false positive, false positive, false negative. Because I've tried to explain that accuracy is not good. We are using confusion matrix as a good measure. And for this model, actually, we're using AUC or ROC curve. So this is the output shown here. So instead of using other methods I've shown in my slide, that the AUC and ROC will give a better results. So this is the thing, the value which is under the curve or above the curve.
Ma'am,
Here it is. Yeah,
excuse me, ma'am.
you tell me.
Ma'am, can you hear me, ma'am?
Hello.
Ma'am, whether you're trying to show the result in Jupyter Notebook, ma'am, or the accuracy, all those things which you're mentioning.
Yeah, come again. Hello.
Hello, ma'am, whether you're trying to show that accuracy, the result which you have got using the Jupyter Notebook, ma'am.
Using various algorithm I've
But
shown.
but we are unable to see that result, ma'am.
No, it's I've shared the entire screen. So far, you have
No,
not seen anything.
yeah, that's what I was telling. I could able to see
Can you
that.
see the? Yeah, what is showing now?
No, the data set alone it is available, ma'am. In Jupyter Notebook, the only the data set it is
No,
available.
I'm showing the code actually.
Okay.
Let me check.
It is. I could able to see the code from line number 1 to 27.
1 to
27 probably. Yes.
27. You're able to see up to 1 to 27.
Yes. With only the CSV file data alone.
No. Okay, I'll change it. I'll show the screen.
Yes.
I've shared the entire window, I remember.
Okay. No, probably would have shared maybe
Okay,
instead of sharing
I'll
the
stop
entire.
this. I'll stop sharing the CSV file and I'll
Yes,
show you
ma'am.
the code now.
Yeah. Fine.
Is it visible now? The code? Hello?
Yes, ma'am. Now it is visible, ma'am.
I think almost I'm done.
Okay.
Okay,
Okay.
fine. But I've informed it earlier.
Yes.
Okay. So I've imported the necessary libraries. Okay, I've shown algorithm efficiency for the same data set, telecom industry data set, for logistic regression, and then KNN, uh, then random forestry, a variant of decision tree. Uh, and this is the data set, customer churn data set that is in the CSV format. And then I try this just displaying the data set here using this. I try to read the data set and then I have displayed the first 5 rows from CSV file using head of keyboard. Then I've tried to display the shape like the number of rows and number of columns I had. There's 4 3s and 3,333 records I have and 21 columns are there. And this just shows the columns what I have. Like as I already just explained, the CSV file had details about the state, account length, how long is a customer for that service provider, area code, phone number, and the international plan, and so on. Like the frequency of calls, how many times what is the frequency of calls and the duration of calls and evening calls are he is making calls during night time or daytime. All these factors are taken into consideration. And churn is a variable which is shown here. This is the output, like whether the customer is going to be a churn or he is not. Based on this output, the telecom, the service provider can decide. They can concentrate on this particular group. You don't have to cover the entire community, and just by making calls to them, and they will get frustrated if you ask them whether they are satisfied with the service and you repeatedly ask the same monotonous questions. Then the customer will not be happy. So you're actually based on the data you have, you try to find the pattern, like whether he's a valuable customer or he is not happy with the service provider, and how he is going to react. Okay, whether he'll quit the service soon, or he's not happy with some services. All this you are predicting it and you are going to address only this category. Okay, so according to this data set we have taken, uh, data set I have taken, it shows 15 percentage of the people are churn, like they're likely to withdraw their service from the service provider, so they can address those people. And this can be applied for banking or anywhere wherever the customer role is important, they can apply this. And this chart is showing you like how many I mean churn rate of this, like false is 85 percentage of the people are not churned, like it is showing 85 percentage of the customers are happy and only 15 percentage is not happy. And this is that description function just shows the account length and data. And again, I'm getting into exploratory data analytics. This just shows the state-wise details of customers, churn customers. Actually, in the x-axis, it's showing the state details and you have false and true columns. All the blue lines will be false, meaning the customers are not churned, and the small one is showing the churn customer. This is with respect to every state. And so the conclusion is maximum number of customers have been found in state WB. And states where churning rates high are listed out here. This diagram, based on the area code. So I've taken the area code with maximum number of customers, 408, 415, and 513. So maximum customers in the area code is 415, and churn rate is also more in this category. So it just shows no and yes, like how many people are there in that city and how many are likely to withdraw their service. This is with respect to voice mail plan. This is with respect to international plan. If they're not happy with international plan services, then there is a chance of churning. And then to deal with the logistic regression, we need to find the categorical columns which are used in the CSV file. And we have 4 data sets here: state, phone number, international plan, SR node, and voice mail plan. So these are all columns that are identified. And getting into logistic regression. And we try to split the data set into training and testing. 70-30 percentage is considered. For cross validation, we considered k-fold method by assuming records in a fixed length fashion, and then stratified k cross fold method. And then random training set are taken for testing, and the accuracy of the logistic regression is this. This is the accuracy of logistic regression. It's almost say 87 percentage of maximum 85 percentage is achieved for this. And the random classifier is shown here using the same accuracy measures, same cross validation method. It is done, so it gave a better accuracy than logistic regression. This is nearest neighbor algorithm. and k value is decided as 5. K value is decided as 5. So for after deciding k value, then we try to implement it for the whole data set, and same cross validation methods are applied, and you get the accuracy around 89%. And this is the confusion matrix, which shows false positive and true negative, all four possibilities, true positive, true negative, or false positive, false negative in this case. And finally, ROC curve is shown here, receiver operating characteristics, okay, it is shown here. So Y label as true positive rate, and X label is false positive rate. That is the that is shown. So that's all. I think I think uh, I think I'm done. If you have any queries, you can ask me. Yeah, actually, this entropy calculation I've shown on this slide. I remember. I'll share the slides with you. Can I hear from the organizer?
Yes, ma'am.
Uh,
Ma'am?
yeah, that's all, ma'am. That's all I have.
Oh, okay. Okay, ma'am. Fine. So,
I'll share the slides with
yeah,
you.
yeah, yeah.
And in the slide, I've showed the someone asked
The
how to
entropy
calculate
calculation.
entropy decision trees that I've shown on the slide itself. I've shown two types, Gini index and also the entropy method calculation by
Sure.
showing the formula.
Okay,
I
sure, ma'am. We will share that with all the participants. Okay. So,
Dr. Thenmozhi ma'am, I thank you for putting your effort. And we started with the basics of machine learning algorithm, and finally you gave some beautiful representations of algorithm using Jupyter Notebook. So it will be really useful for all the participants, especially those who are having their hands on machine learning. Definitely, your session will be really useful for them. And finally, you also have compared taking a data of from company, and then you have done the analysis using all the algorithms that you have taught in today's session. So it was really useful to us, ma'am. And I once again thank you on behalf of DSU for spending your valuable time for us, ma'am. Thank you once again, ma'am.
Uh, thank you. I really thank the organizers, especially Dr. Shiva Ramakrishnan. Uh, he was very, friendly, and whenever I approach him, he is always there to guide me. It's a great opportunity for me to share my views on machine learning. Thanks for the cooperation. Thank you.
Thank you, ma'am. And in future also, we like to have the same support from yourself and your organization, ma'am.
Sure, if I'm given an opportunity, I'm always ready to do it.
Thank you once again, ma'am.
Thank you, Manana.
I would also thank all our participants for attending this today's session. And tomorrow we will have the last session of the 6-day workshop, again at the same time, 2 p.m. So I hope we meet again at tomorrow, 2 p.m. Thank you, one and all.
Thank you.